Hey everybody, my name is John Shishilla with Honor Services. I'm a home inspector, and this presentation was actually put together for the South Florida Roofing Contractors Association meeting a couple weeks ago. And after some, debate with them and discussion, I decided to record it so they could kind of see the whole thing. So this will help roofers and inspectors kind of look at what we're looking at for roof to wall connections in reference to wind mitigation and the Uniform Mitigation Verification Inspection form OIR B1 1802. So my wife originally did the presentation with me, and but she's not here for the recording, so I'm just going to go ahead and get into it. But she is an owner of part owner of my construction company. We've been in business since 2008, and she is currently the director for international program director for the My Safe Florida Home program. She does have a Bachelor of Arts degree at Wayne State in office management, and she's worked with Wolfpack Advising as a business consultant and conference planner. So a little bit about me. So I am a licensed home inspector, number 21 in the state of Florida, licensed mold assessor, residential contractor, certified pest control operator, former president of Florida Association of Building Inspectors. I've been a member of the International Association of Certified Home Inspectors for 15 years, past member of American Society of Home Inspectors, and I've owned Honor Services where we do it's Honor Construction, but DBA Honor Services, home inspections and pest control. We've been doing that. I've been doing inspections myself since 2006 or seven. So anyway, that's that there. And yes, I do advise my wife on the My Safe Florida Home program. So anyway, the My Safe Florida Home program, this is March 2024, and they've appropriated another $200 million in non-reoccurring funds, $7 million for administrative costs for the 2025 fiscal year. So this new program is going to be a little different than the last go around, but it'll be rated towards lower income and people residents over 60. So it'll prioritize those. Not that nobody else will be available to get funds, but um, will prioritize those. So it's more my wife's jurisdiction. So, but there's will be no contractors list on this one. So any contractor who is licensed will be allowed to get funds for these grants. So, and of course, they'll be matching in low income grants. Uh, you can go to my Safe Florida Home website if you want to find out some more. I recommend reading all their documentation, watching their videos, that kind of stuff. This here is just to augment because we've been seeing some issues. So that's how this came about. So one thing a contractor should do is ask if if they applied for an inspection, did they apply for the grant? Two different steps. Are they approved for the grant? I'd ask for the paperwork. Let's see it. Um, the homeowner is the driver of the process. So again, you can get that information off the My Safe Florida Home website. So, but wind mitigation is the strengthening of existing structures to resist hurricanes. So we're going to mitigate the wind, right? And what we call one of the things we do here, the wind mitigation form looks at several things, but one of them here is the roof to wall connection. So we look at retrofitting straps or clips to the roof to wall connection, meaning the roof structure to the wall structure. So, we talk about this and estimated cost. This could vary greatly depending upon how it's done, when it's done. If you have soffits that are hard to get into and you have to do them from underneath because you're not changing the roof at the same time, can get very expensive very quickly. So, estimated cost, that's something, gets thrown around, and I'm sure it's more like 35 now average, but could be more. And it really depends on what the access is. So it really is a case by case basis. So, and it depends what kind of straps or clips they need to add because some of those clips or straps run $10 a piece just to purchase them. So that being said, I always like to point this out, and I've been teaching wind mitigation for a long time now, and this is one of my early pictures, and I like to point this out because a lot of people just don't look at these things. So a roofer may see it from the top, and an inspector may not know exactly what they're looking at, or they just don't deal with this on a regular basis. But these are your hurricane clips. So this is a wood frame wall. You can tell because it's wood on the top, and this is a roof truss and the roof deck. And some of this I've used for presentations to realtors and things like that. So, or even insurance agents or homeowners. So just an idea, so we're all on the same page here. So we do have possibilities for how we can connect this roof to wall. There's different ways it can be done. This is a masonry example of different connectors attached to masonry. So there's options. There's lots of options there on how this can be done. But the key is no matter which option you pick, it has to be done correctly. So you can't mutilate the connector. You cannot change it or use it for a purpose which it wasn't intended. And I'll come back to that in a little bit, but here you go, there's that there. So here's a wood frame, wood to wood. This happens to be a block wall with wood on top, so we can use a wood to wood. So, and again, some other options we have here. We have typical hurricane clip there in the middle and on the right side. So there's different options you can do. So one thing we want to do make sure is also this top plate is bolted down as well. You want to connect it to something that's not attached. So we're looking for what we call a continuous load path. So that's part of the making sure that happens. So the wind mitigation form, if you're going to be doing retrofits or if you're going to looking at getting retrofits, you really should read the wind mitigation form. This is a section of the OIR B1 1802. And you really want to read all the definitions. And one of the things I'm going to tell you here is minimum conditions to qualify for B, C, and D. So these first two checkboxes underneath that underlined section, they must be in place for you to get clips, single wraps, double wraps. So those are minimum. Those, you always have to have 3 nails secured to the truss or rafter. And you also have attached to the top plate or wall framing or embedded in the bottom beam with less than a ½ inch gap. So we'll come back to some of this because I'll have some examples. So in order to get clips, you have or straps, single wraps, you have to mark both those boxes have to be checked off and good. Okay. So then we have our clips, which are metal connectors that don't wrap over the top of the truss or rafter. So and then we have one that wraps over, but the nails are not in the correct placement. So those are both counted as clips. So we'll go through some of that. And then single wraps is a single strap that wraps over the top of the truss or rafter and is secured with a minimum of two nails on the front side and one on the opposite side. So it goes up, over, 2 on the upside and 1 on the downside. So I didn't make the rules. That's just the way it says it. So if you don't have that, you can't get single wraps. It would fall back to 3 nails and be a clip. So double wraps is 2 straps on opposing sides and wrapping over. Not very common, but they are out there. So here's an example of a clip. And what you don't see is that, even if you may have had 2 nails on this visible side underneath this word clip, you have another side to it you can't see. So this is like a U-shaped clip. It was shown in the graphic earlier, but that blue arrow shows you where the other side is. So you always have to check both sides to make sure you have what you need. So and here's a diamond-shaped clip, and this one, I think this one has 2 nails on each side, or it's 3 on each side. So again, another example of a clip for you. This is 2 examples of clips, the metal connectors that don't wrap over. So you'll notice one on the top left side of the screen, it looks like it only has 2 nails. So we're going to ignore that for the moment, but that's a typical H clip as we call it. And then we have a strap. So not to include a strap and confuse it with a wrap, but a strap is a wrap is a strap that wraps over the top. So this is a clip. So regardless of how many nails in it, this is the way the form was made. This is considered a clip credit. So we have to have a minimum of 3 nails, like we said. We have to have the nails in the correct position for a wrap. So those are highlighted here on the screen for you. So, and remember, we're also checking every truss and rafter we can see. So if we find one that doesn't meet this definition, it gets, I call it downgraded. It gets, the lesser. So the least, the weakest, which is listed there at the top of the form. So it's said there. So here's a clip. This is obviously an open ceiling. You can't see it. So this makes a great picture. And this one here, we notice we have 2 nails connected to the roof rafter. So we could add a 3rd nail to this one and it would meet the definition. And I know in some parts of Florida, you'd have to add the 4th. So you can add the 4th, and it's always a good idea to fill all the holes, but we'll come back to that. But we also have to realize down below it's not connected properly. If we can see that, we have to fix that as well. And if we see that, we have to report that. So even if you put the 2 nails in the top left and you had 2 in the bottom right, it wouldn't count if it was seen. We're allowed to assume that the nails match if we can't see them, because we know most of the time you can't see this. This is kind of a unique situation. It was taken in a garage with an open ceiling, and that's why we took it, because it made a perfect example of what we can see and what we can't see. So we normally would not see that bottom portion, which is the wall. So we don't have to check that if we can't see it, but if we can see it, we have to check it. And if it's wrong, it has to be fixed. So that's where we're at here. So here we are. We have, this is actually a retrofit strap. Somebody added after the fact, because you could tell there's a concrete bond beam. Generally, people will set those straps in the bond beam as the concrete cures, and that allows them to set the truss next to it and then wrap it over when they're done setting the truss. This one was attached on the outside, which more than likely means they missed it, or they misplaced them, or they forgot, or whatever. But they added these after the fact, so they're probably Tapcon to that bond beam on the wall, and they have 2 nails going up on this side, and then you have the extra nails on the opposite side. So this is a wrap credit. It has more than 3 nails. It's perfect. This strap is perfect. The problem arises when you get to the next one. It only has 1 nail on I call it the upside, the side that's connected to the wall. So we only have 1 nail here. So when we go back over and we look at I'll go back to that. When we look back at the other one, we see there's plenty of nails. Even though we may have 3 nails, now this would be marked, if it has the 3 nails, would be marked as a clip because it doesn't have the nails in the proper spot. So here's an example of a clip that's been not free of visible corrosion. That's why I said read the form. So this is severe corrosion. It needed to be replaced, and of course they did. They added another clip on the opposite side. So they did a great job here, and we'll come back to some of that in a little bit. So this is one. This was brought to me by Manny Gonzalez, and it was interesting. It looks like a wrap from this side here. You can't see both sides, but the problem with this is a wood frame wall, and this strap is connected only to the stucco. So that would be an improper install. The strap, it's required to be screwed to the framing member, so the roof framing. So we don't really know. I mean, we can't tell from the picture. So, but when you have wood frame, the stucco should not be in between the strap and the structure. So it has to be structure to structure. And stucco is generally not considered a structural item. So this is a bad way to install this. You have to find a different way of doing this. So here's what we consider a quintessential wrap. It's a bond beam. They set it in the concrete. They wrapped it over the top. They got plenty of nails. They're in good shape. So that's what that looks like. This over here. So now here's an argument that inspectors like to have. This strap, we'll forget the point that it's probably a bearing point. It's not an exterior wall. It's probably a patio wall, and there may be a header out there that it's connected to as well. But it's a good example because we can see the whole thing. This is not wrapped over the top cord of the truss. It's wrapped over the top of the truss. So it's interesting because some inspectors will say, well, in order for you to get a wrap credit, it has to wrap over the whole truss itself, meaning the top cord. This is a web member. I disagree. I think a wrap is a wrap is a wrap. If it wraps over the top cord, great. I'm be more concerned about the fact that they put nails through the gusset plate, but you know. But this looks good. This would do the job, and you'd have to have catastrophic failure for this to fail. So this would be, to me, an acceptable way of doing it. Again, I'm careful putting nails through a gusset plate. Those really should not be altered in any which way. But this was probably done when they built the house, and nobody thought about the layout when they did it. So there you go. So here's a example of a double wrap. It's on one on each side. So it's wraps, it nails on both sides. We're good to go. All the holes are full. Awesome. So this is a Sanibel type. This is not a Sanibel strap, but it's a Sanibel type made by a different company. Sometimes you'll see these wrap over the top and are nailed to the wall on both sides. They may have no nails into the truss or rafter at all. But since it's secured on both sides, it stops that movement of the truss. And since the truss can't move, we give it what we call a double wrap credit. So we would mark this as a double wrap, even if it had no nails that were visible. We're allowed to assume that there's at least 3 nails on each side because we can't see it, attaching it to the wall. So that's just an assumption we have to make because there's no real great way to see that. So here's some examples of a Sanibel wrap. double wrap, as we call it. And these are roof to wall. There's also some, other connectors in there. You can see there's some stud to top plate connectors. So this is how we get this continuous load path. You have to be careful with stuff like the one on the right there on the top. And there's actually a little bit of a gap there because they couldn't get the strap in correctly, or they pulled it out and they couldn't get it up to the stud. The stud was kind of in the way. So you got to be careful with stuff like that. You may have to use a different connector if you have issues like that. If that stud was a little further over, you may not be able to use it. So that has to be taken into consideration. So here we are. Here's just some of the graphics of the same. You can tap on it to the block on either side would work, and or you can wrap it over the top plate as you saw in the previous picture. So there's a Sanibel type. So Sanibel, this is what they look like. This is from the USP connectors. So like I said, I like to use the manufacturer. So one thing you should get used to is if you're going to use a clip, strap, wrapper, any metal connectors, get the paperwork on it, look it up, and also check out the fasteners. What fasteners are required, how many are required, because if you use improper fasteners, then it's not going to work. So you have to check with each. Usually, even on the box, they'll say which fasteners can be used, and it'll say either this nail or this screw. And don't try to think, oh, I'll just use something else. It's not going to work. If anybody's used a drywall screw for the wrong reason, you get what I'm talking about here. It has to be the correct fastener, and it has to be, you're supposed to fill all the holes that are required to be filled. So reading the box, the directions is probably a good way to go. So also, I like to point this out, and this is a Simpson strong drive screw. This is a screw that's installed in new construction lately, pretty popular in North Florida. This screw is not a very good retrofit screw because a lot of times we don't have access to the wall and the top plate. So this screw here is done a lot of times, and there'd be no visible sign there was anything there. But we give this a clip credit. I know it doesn't meet the definition of the form, but the uplift of it does. So it'd be silly to say that a new house didn't have a clip. So this is kind of where we're at. We give it the clip credit. There are alternate ones of these, and there's alternate ways of installing them. Just make sure that if you're going to do these, you're following the directions, you're getting the angles correct, and using the appropriate number. So again, this is available online. You can look it up, but this is how their directions on how to install them and how they should be used. And you'll see that they're not just for roof-to-wall connections. They make them for some other things. They also make a guide system to install them. So this one I think is Simpson's. So there you go. So here's a picture. That's brother Mike right there. He's retrofitting some straps on my concrete block house. So you'll notice that this is we just bought the house and we needed a retrofit right away. And Joe is working with him there. Joe's my roofer inspector buddy, and they're pulling down soffits. A messy way to do it, but it can be done. Also notice they have a can of wasp spray right there. You know why? Because there's wasps. So just there you go. So interesting enough, here's a picture of some of their completed work. These straps were too long and they bent them backwards. In theory, you can't bend them back again to make them wraps, but that's how they did it. They filled enough holes. They made it work. In theory, the straps should not be deformed more than once if they're allowed to be deformed. So, but this is what they used. So there you go. So we always check three or more rafters in a row. Why? Because or trusses in a row because we want to make sure that it wasn't put on in every other one. So we also, when we check for these, we don't look in the corners. Corner uplift requirements can be much different. You'd have to refer to the engineering and decide how to do it. I would tell you if you're doing a retrofit, you put them everyone you can get to. Corners will be ignored usually by the inspector, usually within 5 feet or 6 feet, depending upon where you look. But we just ignore those corners. But I would tell you, it's probably a really good idea on this gable end here to put one in there. It's just a great idea. Would probably be advantageous to rebrace that gable end too, but we get into that. Here's an interesting one. This was brought up by Brian Hoagland. He's a employee of ours. He's been in the business much longer than I have, and he found this in somebody's house. They chained their roof down. Might work, might not. I don't know, but it was interesting. I guess they had the chain, they had the bolts. Why not? So here's some examples of poorly installed straps, and hard to see, but there's probably not enough nails, and the one on the left is not secured except for one nail on the left side and the bottom. and it's too far from the truss. If you have a 1/4 inch gap or ½ inch gap, it has to be fixed. So this one was sent to me by Jason Rand. They put all the nails on one side, not on the upside. So this would be a clip credit, but it's probably too far from the truss as well on the bottom left there. This is a really old one, only had one nail. So this is an example of stuff what we find inside attics. So here we are. This is probably your typical 90s house where they just didn't pay attention to layout. And of course, this strap is definitely too far from the truss. It's more than ½ inch. Here's another picture of how we measure that gap. And again, it comes out of the block more than ½ inch off. It's almost 3 inches off. So here are some more examples of what not to do, what shouldn't be done, and why you might need to fix them. These need to be retrofitted. Here's another one. They were, what, a foot off? I don't know. So here is a blocking. So this is why I put this picture here. This is a block. They filled in the space between the truss and the strap coming out of the concrete, and they filled it in. Now, I could tell you it's probably better to block the whole truss or the whole rafter, but I'm not mad about this. They did this. It's probably going to work pretty well. They did deform the strap, so you start talking about weakening the strap, the nails on an angle, things like that. So you probably really need to block the whole truss or rafter. You need to go all the way up to the roof deck to the top plate or the bottom beam. So it would be a much better way of doing that. But that might require 2 pieces of wood stacked or a piece of plywood cut. But we're allowed to block up to, we have to block anything over ½ inch or ½ inch or over, and we're allowed to block up to 1.5 inches, which happens to be our nominal dimensional lumber that we use for construction. So that's how we would do that. If it's further than that, don't bother blocking it. Don't just add another one. So we want to make sure that our connections qualify. And here again is just to look at it. It's just a great idea to keep it, copy this form around and read it before you do these things. And make sure you're going over it. You understand all the questions. And by the way, you can always ask. I'm happy to ask here. I'm around. You can post it. We have some Facebook groups I'm in, and you can post on our website, stronger.floridahomes.com. So I'm happy. I'm even willing to look at pictures. This came from, I think, a roofer, and they used the flat strap. So this strap was designed for wall to floor to wall. So for a 2-story house, you put this flat strap and you strap all that stuff together. And again, it was bent over and nailed, and they're not designed to do that. So you can tell by looking at the thickness is much thinner than the strap that's currently there, but missed all. So this strap right here, this came up in one of the Facebook groups, and I don't know the exact number on it, but some of these are not designed to do this. Some are. You got to make sure they're designed for a roof-to-wall connection, and you have the plans and the engineering on it. This one, it looks like uses one bolt, and the plans were a little hard to read. So just be careful with what you're getting. They all come up with a lettering system or a numbering system on what they are. Look them up, see if and what the manufacturer says it's used for. Because just because it'll work doesn't mean it's designed for that purpose, and the manufacturer will not stand behind it. So somebody used, this is HGA, I think it is called, and they were doing a wood-to-wood connector here. These are great. They're one of the few connectors you can attach from the top straight down, but they missed. So they were getting no credit. There's 3 screws, 2 screws are in the truss, and they're just not right, so they missed. So here's another example of a bad install. Again, a flat strap used in the improper way. What happens is, as the uplift comes, it puts pressure on one screw at a time, so it has a cascading or a zipper effect failure. So one will fail, then the next one will fail, and the next one. So this is why the manufacturers will not allow this. Where on this one they allow it because it's a much thicker gauge, and that, I don't know what you call it, that bend in it makes it much stronger. So this doesn't have any of that. So make sure you're using the correct product. Again, here's an example of how not to do it. Just because it has the 3 nails doesn't make it fly. This metal connector is not designed for this. You can actually see the old connector with 2 nails in it on the left there, but it's not designed to be installed this way, so there would be no credit for that, and it would be a false sense of security. Here, what I want to point out is on the one picture on the left, looks like we have 1 nail. It looks like we have 2 on the right. That is not a nail on the bottom. That is actually a rivet. So these trusses are not supposed to be, or rafters a lot of times are not supposed to be in contact with concrete. So they make straps, clips, and things like that with a plate in them, a saddle you might say, and that plate keeps the truss off of the off the concrete. So sometimes we use roofing materials and put under there. There's all kinds of things that are done, but this is not a nail; that's a rivet on the bottom. So this one only has two nails, so it doesn't even get clip credit. So. Um, there are other ways to do it. There's toenails, if you ever seen that. It's a lot of times what we're retrofitting. They make structural anchor bolts, which we talked about. You can't always see. Straps that don't wrap are more than a half a way of truss. We have straps or clips that don't meet the nail position requirements. So, there's all kinds of things we can find here, and hopefully I give you some good examples here. We're looking for the weakest link. So, this is the part that gets a lot of homeowners mad is one inspector will go in and say, oh, this looks great. Then another inspector will go a little different direction or dig a little further and say, no, it's not. So it's important that when we're retrofitting, we're doing all of them, not just one or two, because eventually, one thing we say in the inspection industry, there will be somebody behind you. There was somebody before you, and there will be somebody behind you. The number of inspections we do in Florida is crazy with wind mits, 4 points, and home inspections. The house turnover is quicker here, longer. So just remember that somebody will go behind, and obviously we don't want somebody upset because somebody skipped some. I'm going to touch on this briefly. SWR versus SWB, secondary water barrier. Secondary water barrier is required by code. 2 layers of felt, two layers. Okay. SWR is called a sealed roof deck, or secondary water resistance is a peel and stick or a self-adhering polymer modified bitumen roofing underlayment applied directly to the sheathing. So it has to be directly to the sheathing. You can tape the seams if you want, but it has to be directly in the sheathing. And I know a lot of people, especially South Florida, are like, no, that's not how we do that. I understand. But to get the credit, that's the way it has to be. So it can't be a hot mop system. Felts do not apply, do not qualify. It has to be self-adhering polymer modified bitumen roofing applied directly to the sheathing. Okay, or a foam adhesive underneath that's designed for that purpose. So here's some examples. Somebody was taping the seams. So great. You look at it from the attic, we see the shiny stuff. That's kind of what we look for when we do the inspection, because we don't, inspectors generally are not there when their roofing is being done. So you can see this roofer was going to seal the seams, and they were putting tar paper over the top. So here we are. We had too many seams, so they used a full peel and stick product, because obviously you have a deck system like this, you'd have just tape on top of tape. That just wouldn't work. So um, just remember, there's Florida Building Code requires SWB, but the insurance companies require an SWR. They're two different things. The SWR must be self-adhering directly to the roof deck, not over tar paper, not over synthetic. We can argue about the benefits of either direction all day long. I've been in Central Florida. We've been using peel and stick on roof decks since 2007 on a regular basis. Not really see much of a problem with it yet, but we'll see how that goes. I think the second layer and things like that become a problem, or repairs become a problem. I get all that. So um, if you don't like that, you can always use the seam seal tape, and just use synthetic or something over the top of that would be great. So we always need proof. We need proof of everything. Inspectors always need proof. So we like to see it on the receipts. This one is quite a few years old. It's from 2007 actually, and you can see that he added $3,710 for peel and stick. So, and that was in 2007. So let's talk about this for a minute. Not very popular in South Florida, but very popular in North Florida. Huber's zip system, or Huber, however you want to pronounce it. I don't know how to pronounce your name, but a zip system. So this is the seams are all sealed with their zip tape. It's my understanding they don't need any other underlayment because of the coating on it and this and that. Again, we can all argue about that, but that should be good to go right there. So. If we see their logo or anything in the attic, we know it's this, and we know it's supposed to be sealed, so we're fine with this SWR. So here's some examples of SWR in a attic. This is an older house, obviously got a dimensional lumber roof deck, and you can see it. The gaps are probably too far apart. Something you have to kind of consider when you look at doing roofing is the manufacturer's maximum spacing below the shingles. So something to think about. So this is the original My Safe Florida Home program. This came from one of their slides, and this is the foam adhesive they used as a SWR and a roof deck attachment. So this was in lieu of renailing the roof deck. So here's an example I found. You can see where they sprayed it and it adhered everything and it seals everything. So just a funny picture of my screwdriver sticking to the ridge vent that was cut out, but no vent was put in, and there's peel and stick over the top of it. So one thing we teach inspectors, and I'll go back to that, is don't look in the valleys, don't look near penetrations for SWR. Those are bad spots. Usually, there can be a combination of stuff on a roof, so we're trying to look in between the plywood and spots where it wouldn't be used as almost like a flashing. So here are some foam sealant. So again, same thing. Here's some confirming SWR. Again, I don't know. I guess that's the ridge vent again. So I'm not going to go into too much roof geometry, but I wanted to talk about it briefly because roof geometry is a math problem. It's not what I think it is. It's a math problem. So, we take the perimeter of the house, we measure the whole perimeter, and then we measure all other roof shapes, not gable roofs, not all other roof shapes. So this house here, when you look at the front, the blue lines are considered hip. The red line is considered other, and that's how we measure it straight across like that, as if it was flattened to the ground. And that's our other. The yellow is not counted because it's attached to the wall and it's not part of the inside of the house. So that comes into play in patios quite a bit. So here we are. We have our hip and we have our other. So we have our hip and we have our other. We have our hip and our other. So these are our roof shapes. So it's very easy to get to, get 10% of a perimeter of a roof. A typical house is, 230 feet around. When you measure perimeter at the roof, and then that means you need 23 feet of other roof shape. It doesn't take a whole lot. So this is an interesting one because these homes here, everybody says, well, my neighbor got hip roof. I got the same roof they do. They built at the same time. Well, do the math. The one on the left might not be. The one on the right probably is. The one in the middle definitely is. So this is what we call all hip roofs. So another thing to point out here is this center roof here that's raised. It's considered other roof shape. So we measure that across, not along the rake like that, but we measure straight across but there's just no way to draw that line correctly. So this one's not counted. Again, it's not counted because it's not connected to the main roof system of the house. It's below, it's attached to the wall. So this one is counted, it's attached to the roof system. So this whole perimeter here, it's a low slope roof, so it's considered a low slope. So the whole perimeter, outside perimeter of this roof is considered other. So obviously. This one here is not counted. Again, it's attached to the wall or the fascia, and this flat section roof is not counted as part of the roof geometry. So here's an interesting one. We have a gable on the left, but this room on the right, you would say, is not counted because it's attached to the wall. Unfortunately, they took the sliding glass door out, opened it up, made it part of the residence, and now it is part of the house. So here's an example here of that. Does it count? It's a light metal construction roof. Shouldn't count at all until you realize, yep, it doesn't count, right? But when you look inside, they took out the doors and windows. So now they made this light metal construction roof part of the interior of the house. So it does count. Not only is it unsafe, doesn't meet code, but they're not getting hip roof credit for that. So it's going to count on that calculations. So here we are. The yellow is our other. The red is also other because it's a low slope roof. It's not a hip. So these are non-hip features. We don't measure valleys or transitions, so slope transitions don't get measured. This one is, people always forget, go, oh, well, it's all hip across the front. Well, no, it's a low slope roof, so it's not. Again, this one, the inspector missed it, and they put the green line as perimeter, but the red line, they didn't see that from below. The red line is the other shape. So they're going to measure this, and they're going to measure it not because it's because it's a vulnerable section of the roof, and it doesn't slope down. So again, here's some more examples of the same kind of thing. That red line there on the bottom one is going to be our other shape. So we're not measuring the valleys. We're not measuring those transitions. We're measuring exposed roof edges. So it's kind of where we're at with that. So here we are. Here's some other, measurements is how we measure these others. So again, not going to go too far into it. This valley doesn't count at all. It's got very little exposed edge, so it came up as a question. But here's an example. This came up. I forget who made this. It might have been Bill York made this graphic. It's been kicking around for many, many years. But this is how you measure a roof. So you're basically going to flatten it out and you'll measure it that way. So, but this graphic gives you that in a nutshell. It has pretty much everything kind of feature you can have to think about it. So. Anyway, so that's that. I just wanted to get this out there for you and give you a chance to look at it. And I'd love to hear your comments, your feedback, and if you have any questions about these, these roofing issues and retrofitting, I'd love to hear them. Thanks a lot.